Okay, so we're in intergalactic space, and I hope you'll enjoy the ride. For the moment, we need to reach higher than light speed, and of course, when the moment is over, while we're moving to the edge of the universe, you might want to prolong the excitement a little bit to another position that you perhaps have not thought exists. Um, Namely, the position of the edge of the universe. Okay, so we're driving through the universe and we will do a turn at the edge to see the whole thing from the side. Now, the new version of Space Engine, you could do this easily because the whole universe is visual. This version is good. There we go. Alright, so let's see if we can find the edge of it. There we go. Now, just to inform you that we have the universe on the right, and we're going to try and take a circumference around it with the diagonal or radius continuously being where we are. So now you realize the limitation. We can only actually use 3 or 4 vectors going around the universe. The thing about this is that we are taking 1 arc second for every, I think, minute of going around this universe. So it just kind of shows you that the whole 360 view is quite massive. And excuse me, if you feel that there should be another universe right next to us, let's see, there we are. It's probably because our rotation is 0, 360, right? As 0, 1 arc second. So anyway, I'm going to try to move up and above the universe on top of it, and we'll just try to find the position, you know when you look up at the night sky and you see that thing out there, the North Polar Star. I'm sure the universe has its own polar stars, or polar galaxies, should I say. Much like these bright objects here. Now if we can get this one on the edge, we actually see that the polar position still has a bit of a small radius outwards. So in terms of other universes, this polar galaxy could actually be baked into our own universe as a type of, well, navigation thing, I don't know. But assuming we are going around the universe and trying to find the up position, there's a lot of these very bright galaxies. Now, I'm not counting, but in reference, I'll try to be as fast as I can. the universe does seem to be regular, and there are some positions that display these red points. Now I'm sure they're linked by in some way to the polar galaxy by the so we're just cutting an angle through the edge of the universe here. Now they're red, but as you approach them they get orangey. Alright, let's just try and exit again. I'll lose my direction. There we go. And they seem to be distributed quite evenly. You can see all those red points turning to orange. Now, why are they at the edge? Well, that's probably because they're redshifted the most. And as this program goes, it's only a few computations. So it's quite an attractive feature of this that it's actually showing it shifts. No, perhaps, I mean, we don't see it as a solid wall, right? We're on the edge here. And the Sloan galaxy feature that does exist in the center by about 2 billion light years. And the probability of it being a measure of the polar galaxies from going from bright white to red to orange is probably stored as a function of computation in the universe. I'm not saying the universe is a computation or a computer program, but just like this universe does have some computational points that work out the basic random functions. Each galaxy could actually also be part of the computation, a random 1 plus minus 2 expansion contraction. So while I'm moving around the universe here, and we want to take a look back as well, right? And let's keep that polar galaxy in view, that little point there on the edge. So you can see it actually does exist outside the main zone. Let's go backward forwards again. Seems like a lonely, dark place, the edge. So I'll leave you with your thoughts on this.